Okay, probability assessment for the higher probability. I'm going to put my name on, Mr. Ronald. That will do. So, here are two statements about probability. Circle agree or disagree to show whether you agree or disagree with each statement. Give a reason for each answer. Okay. When you roll a fair six-sided die, it's harder to roll a 6 than a 4. Okay. No, it's just as likely, isn't it? I disagree because each outcome is equally likely if it's a fair die. Equally likely with a fair die. Okay. There are 3 outcomes in a football match: win, lose, or draw. The probability of winning is therefore 1/3. It seems on the surface like I should agree with that, but let's think about that. What if Rushy Mead were playing against Arsenal? Yeah. Is it going to be equally likely a win, lose, or draw? No, it won't. So I'm going to disagree with that statement because it depends on other factors. Okay. And it depends on other things. So it depends on other factors. Like how good the teams are. Okay. Okay, a bag contains, I'm just going to zoom in a little bit, a bag contains 12 blue and 8 green counters. Give me a minute. Okay. More blue and green counters are added to the bag, such that for every blue counter added, 2 green counters are added. The probability that a counter taken at random is blue is now 0.5. Okay, so it's half. It's a half chance now that I would choose a blue counter or a green counter. How many blue counter and green counters were added to the bag? Well, if it's an even chance that I choose, there must be an equal number in it. So I'm just going to list the situation. So I've got blue counters and I've got green counters. And I start off with 12 blue and 8 green. Then for each 1 blue counter I add, so if I add to 13, I add 2 green. And then I'm going to add another blue counter and another 2 green, and another blue counter and another 2 green, and another blue counter and another 2 green. And look, at this point here, they're equally likely. So the probability that counter taken at random blue is now 0.5 when I've got the same number of blues and greens. So how many blues did I have to add? I had to add 4 blues, and I'm going to have added 8 greens because I added 2 greens for each blue. Okay. Next question. Question 3. Gemma has a box of red, blue, and green pencils. She chooses a pencil at random. The probability that she chooses a red pencil is 0.5. The probability that she chooses a blue pencil is 0.2. What is the probability that Gemma chooses a pencil that is either red or blue? Okay, so the key thing here is if it's red or blue, then I've got the chances of the red or the chance of the blue one. So I've got half a chance that it's red and another 0.2 chances that it's 0.2 probability that it's blue. So I've got a total of 0.7 probability that it's red or blue. Green has got to be what's left because I've got just red, blue and green pencils in there. So it's just whatever's left over. All my probabilities have to add to 1. So this is going to have to be 0.3. Okay, there were 20 pencils in the box originally. How many pencils were green? Right. So there were 20 originally, and if the chance of choosing a green pencil was 0.3, then there must have been, so if there were 10 there would have been 3, so there's 20, there would be 6, or if I can just do 20 times 0.3, which gives me 6 pencils. Okay. Question 4. 40 people take a test, a driving test at Centre A on one day. The table shows the results. A person is chosen at random from the group. What is the probability that the person is male? Well, firstly, I'm going to just look at this table, and I've got 40 people here. Just going to zoom out a little bit. Just check that. Try to see if I can get my focus a little bit better. Bear with me. Oh, I'm making it worse. Hang on. Sorry about this. Okay, that'll do. So I've got 40 people. There we go. Take a test. And so I'm going to fill this in because I've not got everything here. I need to have 40. So I've got 10, I've got 16, I've got 26, 27, 28, 29. So to make it up to 40, I must have had 11 females who failed. That will probably come in handy. There's no marks for it here, but that will probably come in handy. A person is chosen at random from the group. What is the probability that the person is male? Okay, what's the number of males out of the total number of people? So that's 23 males out of a total of 40 in the whole lot. So 23 out of 40. And I can't simplify it from there, so I'm going to leave it like that. A woman is chosen. What's the probability that she passed her test? Well, I'm only now looking at the women, right? I'm not interested in anymore the men at all. I'm just looking at women because it's a woman that's chosen. So I'm looking just at this. So the probability that she passed the test here is 6. Not out of 11, 6 out of the total number that there are. So there's 17 women in total, and 6 of them passed the test. So that's 6 out of 17. All right, question 5. Okay, Matthew has a dice with 3 red faces, 2 blue faces and 1 green face. He throws the dice 300 times. The results are shown in the table. What is the relative frequency of throwing a red? Well, it's just the number of times the red was thrown out of the total number of times. So that's just 153 out of 300. And I would accept that because it doesn't say to simplify it, but I would be able to simplify this. This is definitely has a factor of 3, and the way in which I can tell that is twofold. Firstly, I know that 50 times 3 is 150, and another 3 lots of 1 would be 3, so this could be 51 up here out of 100 if I divide both by 3. The other way I can tell that it's divisible by 3 is these digits. If I add the digits together and they come to a multiple of 3, then they're divisible by 3. So 5, 6, 7, 8 and 9 come to. So that's a multiple of 3, so it must be divisible by 3. So it's 51 out of 100, the relative frequency. Is the dice fair? Yes, it is fair. Reason being, you would expect, if there's 3 red faces, you'd expect the dice to produce about 150 red, roughly. If there's 2 blue faces, you'd expect the dice to produce about 100 blue, and you'd expect with 1 green face to produce about 50 green, because each face should come about 50 times, a sixth of that, right? So this is roughly in the right proportion. So that's the reason I would give. The outcomes appear in roughly the right proportions. The correct proportions. Something like that will do and get you the marks. Okay. A scout group organises a game to raise money. 200 people each pay £2 to play the game. The probability that a person wins is 1/10. Okay, so 1 out of every 10 people wins. So 1 out... I'll just read the whole question. That's a good idea first. The winners each receive £15 and there are no other prizes. How much profit can the scout group expect to make from this game? Okay, so where am I going to start? I can start with the income. 200 people pay £2 to play the game. So that's 200 times by 2 equals 400. That's £400 income. Now, the costs that the scout group are encountering are the prizes that they have to pay out. So they have to pay out in 1/10 of the cases, so that's 1/10 of 200. So it's 200 times by 1/10, which is the same as 200 divided by 10, which is the same as 20 people we expect. 20 people we expect to win. 20 people expected to win. Each will receive £15. So 20 people expected to win multiplied by £15 winning each. So that's 20 multiplied by 15, which is £300. So my profit is my income take away my costs. So that's 400 take away 300, £100. £100 profit they can roughly expect to make from that game. Right, question 7. 3 cards are numbered 1, 3 and 4. 3 discs are numbered 2, 4 and 5. Okay, so I've got here a sample space diagram for this situation. Discs 2, 4 and 5, cards 1, 3 and 4. A game consists of picking 1 card at random and 1 disc at random. The numbers on the card and discs are added together. Complete the table to show all the possible totals. A nice easy couple of marks here. 1 and 2 makes 3, 1 and 4 makes 5, 1 and 5 makes 6, 3 and 2 makes 5, 3 and 4 makes 7, 3 and 5 makes 8, 4 and 2 makes 6, 4 and 4 makes 8, 4 and 5 makes 9. What is the probability of getting a total which is an even number? Okay, so I've got 9 different things that could happen. Yeah, 9 different things that could happen. That's what my sample space diagram is showing me. So it's going to be out of 9. Now my chances of getting an even number, I've got not even, that one's even. 1 way I can do it, 2 ways I can do it, 3 ways, 4 ways I can do it out of 9 possible ways. Okay, in a different game, the probability of getting a total which is an even number is 3/5. What is the probability of getting a total which is an odd number? Well, I'm either going to get an even number or an odd number, so they've got to add to 1. So what do I have to add to 3/5 to get to 1? That must be the probability of getting an odd number, so that is 2 bits. That's question 7. Right, question 8, we're on to some tree diagrams. Starting off with independent events. That means that one event does not affect the other event. I've got events here, events in these columns. What suit he chooses, what shirt he chooses. Let's read the question. Greg has 4 suits. 1 is striped and the other 3 are plain. He also has 10 shirts. 4 are white and the other 6 are coloured. Greg chooses a suit at random and then chooses a shirt at random. Fill in the probabilities on the branches of the tree diagram. Okay, so 1 is striped, the other 3 are plain. So he has 4 suits. 1 is striped, so 1 is striped out of a total of 4 suits, which means that he's got 3 plain out of a total of 4. In the shirts department, he has 4 that are white and the other 6 are coloured. 4 out of 10 are white, 6 out of 10 are coloured. 4 out of 10 are white. It doesn't matter which suit he chooses, the probabilities here are going to stay the same. 6 out of 10 coloured. So, calculate the probability that Greg chooses a plain suit and a coloured shirt. Okay, plain suit, coloured shirt. Multiply along the branches. I've got to do 3/4 multiplied by 6/10. 3 times 6 is 18 out of 10 times 4 is 40. 18 out of 40. I can simplify that, but I didn't ask for it simplified, so I'll still give you the marks. 9 out of 20. Okay. Question 9. At the end of a training program, students have to pass an exam to gain a certificate. The probability of passing the exam at the first attempt is 0.75. Those who fail are allowed to resit. The probability of passing the resit is 0.6. No further attempts are allowed. The tree diagram below shows all the possible outcomes. So on the first attempt, if it's 0.75, the probability of a pass, then it must be the remaining that adds to 1 that's failed. So 3/4 of people are passing, 1/4 of people must be failing, so that's 0.25 on the first attempt. Now if you fail, you're more likely to fail again. You're more likely to fail again than on the first time. You're still more likely to pass on the second time than fail. But so 0.6, this has also got to add to 1, so I've got to have a 0.4 chance of failing on my second occasion if I fail my first occasion. So what is the probability that the student fails to gain a certificate? I'm just going to multiply along the branches. 0.25 multiplied by 0.4, and this is a quarter. A quarter of 0.4, sorry, I'm just going to move that over, apologies. A quarter of 0.4 is just 0.1. It's a quarter of 0.4. You could do 4 times 25 and then put it back in if you want. Put the decimal points back in and use that method. But I can just see that it's a quarter of 0.4 is 0.1. So the probability that the student fails to gain the certificate is 0.1. 200 students take the exam. How many are likely to gain a certificate? Well, it's going to be 0.9 or 90% of 200. 90% of 200. Well, 90% of 100 would be 90. So 90% of 200 is going to be 180. So the answer is 180 are likely to gain the certificate. That's 3 marks. Okay. Now, question 10. This is probably the most difficult question I have seen on a GCSE probability question, but there you go. May well come up with something like this. A box contains 10 coloured discs numbered 1 to 10. The discs numbered 1 to 5 are red, the discs numbered 6 to 9 are blue, the disc numbered 10 is green. A disc is taken at random from the box and is not replaced. A second disc is then taken from the box. Calculate the probability that the 2 discs are the same colour and the numbers on them add to more than 8. Because we've just seen a couple of tree diagram questions, you might be tempted to go with a tree diagram approach here, and that can be successful, but you need to be very careful with it, and at the end you will still need to look at a listing outcomes approach. And I want to look at a listings outcomes approach here really to tackle this problem. So the discs numbered 1 to 5 are red. Discs numbered 6 to 9 are blue. Disc number 10 is green. I've got 10 discs. I'm going to just start to list the possible outcomes, right? So just to get an idea of how many, because I need to know how many outcomes there are in total and how many of the outcomes would be successful, as in would be both the same colour and add to more than 8. That constitutes success. So remember that all probability is successful outcomes. So, and the successful outcomes, I'm going to repeat that in this case, is a successful outcomes over total outcomes. That's what probability is. So in this case, successful outcomes is the same colour and adds to more than 8 out of total outcomes. I want to find this total outcomes to start with, so I need to think about how many possible ways these could be drawn out from the box, right? So I could draw number 1 and number 2. I couldn't draw number 1 again, right, because I've already taken that out. Or I could do 1 and 3, or I could do 1 and 4, or 1 and 5, or 1 and 6, or 1 and 7, or 1 and 8, or 1 and 9, or 1 and 10. Those are all the ways in which I could draw. If I draw 1 out first, these are all the possible things that could happen. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 different ways. If I drew a 2 out first, I could draw a 1 next. I couldn't draw a 2 next, because I've already taken it out, but I could do a 3 next. I could do a 4, I could do a 5, 6, you see where I'm going with this, 7, 8, and 9, or 10. I'm just going to do one more to show you. I've got 9 possible outcomes with drawing a 1 out first. I've got 9 possible outcomes with drawing a 2 out first. If I drew a 3 out first, I've got 3 and 1, 3 and 2. I can't draw 3 and 3 because I've already taken the 3 out, but I can do 3 and 4, 3 and 5, 3 and 6, 3 and 7, 3 and 8, 3 and 9, 3 and 10. Okay. Now, hopefully we can see that I have 9 outcomes for each one that I would draw out first. Right, so I've got 9 outcomes for drawing the 1 out first, 9 for drawing 2 out first, 9 for drawing 3 out first, 9 for drawing 4, 9 for 5, 9 for 6, 9 for 7, 9 for 8, 9 for 9, and 9 for 10 out first as well. So I've got 10 lots of 9 outcomes in total. And that equals 10 times 9 outcomes in total. So 90 outcomes. Okay. Now, so calculate the probability that the two discs are the same colour and the numbers on them add to more than 8. Well, they can't both be green because I've only got one green counter. So I can discount anything that starts with a 10. Right, because if I could draw the 10 out, but it's never going to have both green. I can discount any of these ones with 10 because they're not going to both be green. So I'm only looking at the both red and the both blue. Now, let's think about this one. If I drew both blue, I could do 6 and 7, couldn't I? And that would be both blue and more than 8. So these are my total outcomes possible. I'm going to list my successful outcomes here. So I've got a list of successful outcomes. Well, I've got all my blues. Anything with the blue will be successful because where both things are blue, they're definitely going to add to more than 8. So 6, if I drew 6 out first and 7, that would be a success. If I drew 6 out first and then 8, that would be a success. If I drew 6 out first and then 9, that would be a success. If I drew the 7 out first, I could then draw the 6 afterwards. If I drew the 7 out first, obviously I couldn't draw the 7 again, but I could draw the 8 and the 7 out again, and I could draw the 9. And I could draw out the 8 first. And if I drew out the 8, I could draw a 6, and I could do 8 and 7, I could do 8 and 9. And if I drew the 9 out first, I could then draw a 6. And I could do a 9 and a 7, and a 9, and an 8. So I've got 12 possible outcomes that would be successful if I'm drawing both blues. The question is, how many possible outcomes I have that would add up to more than 8 if I draw both reds? Well, not 1 and 2. In fact, not 1 and 3 or 1 and any of these are not going to add up to more than 8. The only ones that will add up to more than 8 are going to be ones involving 4 and 5. So these what are the ones for blue. That's for blue and blue. And for red and red, it's just I could draw the 4 and the 5. That would get me to more than 8 and they'll both be red. Or I could draw the 5 and the 4. So the other way around, I could draw the 5 out first and then the 4. So I've got total number of successful outcomes, 12 plus these 2, 14 possible successful outcomes out of a total of 90. That's the probability, the number of successful outcomes out of my total number of outcomes. 14 out of 90, I could simplify that to 7 out of 45. and either of these will gain you the full 5 marks for that tough question. That's the end of the feedback on the assessment. I'd like you to use this now to complete the similar questions in the follow-up sheet. Thank you very much.